Welcome. Today I'm going to teach you how to do a simple AI that patrols a platform. Because we're not be using the actual controller, it's not going to be part of the series polished controller. This is just like a bonus content, if you will. So as you can see, you've got that rat moving back and forth, and what you can do is, I've had some exported variables, I'm going to turn that off. And as you notice, he'll move for a set time, stop for a set time. He'll also register when there's a wall as well as a ledge. So let's get into it. Close this down, move this over here. Now, what I'm going to do is I am going to copy and paste some stuff and just go through it, but right now we're going to do something called inheritance, and that's going to be really hard to explain, but it's really important, and it's one of the tools of object-oriented programming that you really should get to grips with. So inheritance, what it's going to mean is we're going to have a parent which is going to contain like all our global variables like our health, our speed, etc., and we'll call that creature, and rat will inherit from the creature. So you could have a wolf that inherits from this creature, and that will also have health. And the reason we do this is that you can define one method and use it across multiple creatures. So if you could have like a take damage, and we know that creatures take damage, so you'd only have to define it in one place, which is really useful. So let's start and make the parent. We're going to make a new scene. We're going to go to other node, make a load kinematic body 2D. I'm going to call this creature. And then what I'm going to do is attach a collision shape. We're going to attach an animation, animated sprite. We're not going to put frames in it, it's important that you don't do that. And then we're going to attach rays. And I'm going to call this ray left, and I'm going to duplicate it and call this ray right. Where are those rays? So what we're going to do is with ray left, just it doesn't really matter really where these go, we'll be changing that in the child. I'm just putting it here. And what these rays are going to do is check for ledges. Obviously this is where our floor is, where my mouse is. Now if there's no longer floor there, we want a ledge, which makes sense, right? We're going to turn this off because the player is on collision 1, and we know that the floors is going to be on 3. So we're going to come back, we're going to select both of these, and we're going to change it to 3. Brilliant. And we're going to make sure they're enabled, and we only need them to be 1 pixel high. And what we're going to do that is we're going to save it now. I've made a folder already called creatures, and this is in our objects. And the reason it's called parents, sorry. And the reason it's called parents is because that's where the parents go, and anything that's a parent, it can be inherited to be a child. So any script really can be inherited from, but it's just nice to group them in the right family tree, if you will. So we just call this creature. And then what I'm going to do is go to our scripts. I'm going to create a script here. New script. We're going to make sure this script is going to be a parent script. So we're going to go to our scripts. We're going to go to our parents. I'm going to call it creature. Yeah, that's right. So what I'm going to do is just copy and paste the variables we're going to be using. And I'll go from here and I'll explain them as well. So we're going to be using the state machine to control idle and move, and I'll explain that as we do it. So we use something called an enum, and all it does is it defines variables here. So I could call another one and call it attack, jump, etc. And what would happen is idle would be 0, move would be 1, attack would be 2, and jump would be 4, 3 even. Don't need to do that though. And it's just an easier way to, rather than using an ID number, we could just use a name, and obviously we want it to be descriptive because we're not computers, we're humans, and we read names better than we do numbers. We've got an exporting variable, and I'm just exporting the type as an enum, and the reason is just that I can change the direction on the fly much easier. This is going to be our move speed, how fast our creature is going to be moving. This gets we've got some variables, and we're going to tie them to our nodes, which we can then use later on. This is going to be our current speed, which is h speed, and this is going to check if we're on a ledge. So if it's false, we're not on a ledge. If it's true, we are. And if we are on a ledge, obviously we want to invert our facing direction. This then says, right, our current state is idle. This is our motion that we're going to be using into the kinematic body's move and slide method, and this is just a way of moving using the physics engine. And up will just determine the physics engine which way is up, which is y minus 1. So what we're going to do here is going to write something called update facing direction, and let's call it here update facing direction. And this is quite a small one, so I'm just going to copy and paste it. So what's going to happen is in the ready we're going to just check which, as the developer, checked right. If it has, then we don't want to flip the R, because by default it's facing right. However, if it's checked left, then we do want to flip the R, so it's facing left. That's all this does. I want to make something called func do physics var delta, and then motion.y equals 0, because the rat will never move on the y, it will move on the left, and that's going to be our h speed, which is our current speed we're currently travelling. And then we'll do the motion equals move and slide, and then our motion, and which way is up, which we define here. Physics process, we move here, so I'm going to use the physics process, and we'll just do physics here, so it'll constantly update in the physics. This way, in fact, it'll be good to have var v speed equals 0. How fast are we moving up or down? And the reason I'm putting that in is that, sure, the rat can't move up and down, but this is a creature, so that a creature could be a bat, right? So that bat can move up and down because it can fly. So it's just good for completion's sake. And what we're going to do is we're going to put some logic for check if we're on a ledge. If left ray, is that right? If left, yeah, if left ray is not colliding, or is right ray not colliding, then it means that one of the ray casts is no longer touching the ground, so obviously we are now on a ledge. So we want to return true, else when neither of them, both of those are still colliding, so we want to turn false because we're not on a ledge. Save that. Match speed, func match speed to direction. So what this is going to do is it's going to update our current speed depending on which way we're facing. So obviously if we're facing right, we want to increase the x. If we're facing left, we want to decrease the x. And that's what that does. Another thing I need to do as well is check if we bump into a wall or if we're on a ledge. If is on wall, so that uses the kinematic body is on wall, which checks if there's a collision to our left or right. Or on ledge, if we're on a ledge, then that means we want to invert what our so which way we're currently facing, we want to invert that, right? So if current direction equals facing direction dot right. If we're facing the right, position dot x minus equals 10, so we want to move it a little bit away from the wall, and I've just used 10. Now if you don't do this, it'll just flip back and forth because it's really hard to explain. So if you touch on a wall and you say, right, you have to turn, you're still touching the wall, so it'll turn back and forth. However, if you touch a wall, move it back, it's no longer touching the wall, you move it and off it goes. That's the best way I can explain that. Current direction equals facing direction dot left, so we want to invert this. Else zips it, right? So let's just copy and paste this because right. Ensure that's right. Brilliant. And then what I want to do is then, because we know that this we have changed direction, then we want to say update facing direction, and all that's doing is it's updating which way the art is facing. That's all it's doing. But the reason I put it here is, rather than in say physics processes, that this will only be called when it's needed, rather than just constantly checking, which just takes up CPU usage, which we don't want to do. Update facing direction. I think that's everything for the creature. I could be wrong, but we'll come back to it if not. So I'm going to save the creature as it is. Now what we need to do is define the child rat. So we're going to make a new node. Actually, no, go back. This is where it's a little bit different. This is how you define a child. So if you want to do a child of creature, we're going to find the creature in this scene here, highlight it, right click it, and then we want to go new inherited scene, and you'll see what this does now. So as you can see, it's made a new scene and it's carbon copy of creature. However, we can change this now, right? Now for this child, we do want an animated sprite, so go to your frames. I'm just going to quickly do it, so idle, and call this move. And the reason I'm calling it move is because if you call it run, a bat can't run, but it can fly, so you want to make the names as encompassing as you can do. So move can be fly or run. I've got this art already. This is up in GitHub if you need to find this art. And I'm going to go to move, run. I know this is 15 looks okay for this one, and I think 10 looks okay for this one, but let's just make sure it's turned on. Let's call this idle. And yeah, I kind of do, I mean, you might not have the placement here, but just make sure these placements make sense. We want to put these a little bit further away from where the wall check is, so that is actually spot on. In fact, I want to make this a little bit smaller though. Oops, wrong one. Collision box. And then you want to make sure the collision box is, yeah, spot on like this. Save this rat, and I'm going to go to the objects, creatures, and let's just save it in creatures. Save. Awesome. Now the rat's going to have a script. We want to remove this script because we're not going to be using it directly like this, so you clear it. Now what we want to do is we want to make a script that calls the creature script. So this is inheriting from the creature script, and to do that we're going to go to extend script. So when you extend something, it just basically means you're a child of that thing you're extending. So let's create. And what we're going to do is we're going to find, so you'll see inherits here, we want to have the folder and we want to find the creature script. Go to your scripts, go to your creatures, nope, use parents, sorry, creature script, open, and then make sure that's everything. Oh, don't forget to put your script, your child script where it needs to be, so scripts, and now it's in creatures, rat, open, create. And as you can see right at the top, rather than saying extends a node, it's extending a script, which is fantastic. And because we know the rat's going to be a kinematic body, it'll work still. So let's move this up. I'm going to go to the rat. I'm going to just put the export variables in. So these are quite simple. This is just going to allow the user to say, hey, is the rat constantly running, it never goes idle? And then else, if this is false, then we're going to use the state machine. So we're going to say, hey, this can stop for 3 seconds, and then it'll run for 5 seconds. Let's go back. Let's move this. Oops, didn't mean to do that. Yeah, let's just do that. Func physics. So on the func physics body, I'm going to say it's ledge check. Oh, yeah. So this is where it gets confusing. You might think, ledge check. You'll see it's there, so we don't have to define it in here. This is the great thing about having a parent, right? It's already here. So all these variables are eligible to us because we are extending from that script. So we can now call its methods and its variables without having to define it again, which is fantastic. Now you can imagine how useful this would be if you had, say, a wolf and a bat and another object. We wouldn't constantly have to rewrite this over and over and over again for every single creature we make because it's already there. So let's go back to our rat. Going to go check on ledge, and then, as I said, check on ledge. So that'll do that logic for us. And the reason I'm doing it here rather than inside the actual creature physics body is it has to be in order. So I've put it in the creature, in the rat script. So we're going to do the constant roam. If we're constantly roaming, then we're going to say match speed direction. So this is going to say update our current speed depending on which way we're currently facing. And then it's going to be Annie.play move. Else, we're going to use the state machine. Do state. So we're going to go func do states var current state, what we're trying to do. If current state equals idle, state's idle. Oh, don't forget to do this. So this is going to check if our current state of the creature, which is defined here, there it is. So it is going to be idle by default. We want to then say, well, let's play the idle animation because we are idle. We want to make sure our current speed is 0 because we don't want to keep moving. We want to then yield. So what this is going to do is it's going to pause this procedure, get tree, and using the get tree we can create a timer. Now this can be done using a node for a little bit more control, and I would recommend that if this was more complicated. But for this purpose, I'm just going to use a create a timer. So it just means that I have to create a node. And then how long we want to wait for, which if we're in idle, so it's going to be idle length. Timeout. And then we're going to say, once we've set this to idle, we're waiting around now for idle length. Once this is finished, we're then going to say state to states move. And then I can go else if current state equals states move. So this is checking how we're moving. Match speed. Oops, forgot to do that again. It's one of the things I forget the most because I'm from C# background. We don't have to do that in C#. It's a bit weird. 2, there we go. And then obviously we're going to be moving. So play move. Same thing again, the yield. We're going to be moving constantly until yield happens, and it'll be move length. And as you can guess, we're just going to flip it back to the state, back to idle. There you go. So as you can see here, if the checkbox is off, it means we're going to do the state machine. So the state machine is constantly called and it's checking what is our current state, and then it'll flip back and forth depending on how long we want to wait for each one. So I think that's everything. We're going to check if it works. First time, normally nothing ever works first time, right? But hopefully it will on this run. It's rat. Drag your rat creature in. Let's just put in or her. Here, I'm just going to put a block down just so we can check if it hits into a block or not. The rat is running at 60, it's not on constant roam. Let's do that. Oops, so I've got an issue here, is colliding. That's the culprit. So you'll see here, I forgot to do that. Also, I noticed as well, if we go to our raycast, it says ray right, and this is actually, sorry, right ray, and this is ray right. So I've got these back to front. So obviously put these in the right place. And let's see now if this works. So he's idle, he hits the wall and goes away. Fantastic, that's what I like to see. Let's just check some other stuff. So let's move that out just to make sure he hits the ledge. Yep, he does. Let's go to the rat, turn him on. So he's constantly on, he never turns off. I just noticed he hits the player then. So what he's doing there is he's treating the player as a wall, and the reason for that, I believe, is we want to go to here, go to the rat, go to the rat's collision, and yeah, he's trying to touch the player. Whoops. There we go. So let's just make sure he doesn't touch a player. Fantastic, that's what I wanted. So yeah, this concludes this tutorial. It's just like a bonus AI thing. I want to extend this to make it so that if he can actually visibly see you, he runs after you and stuff like that. So if you're interested, let me know in the comments and I'll make an AI series. But my next video will be wall jumping as part 3 of the polished platform collision. Polished platform controller. I got there in the end. Right, see you in the next one. Take care. Bye bye.